Hey everybody, we're still in Unit 2 and we're going to be talking about Chapter 10 in this video. Chapter 10 deals with molecules and chemical formulas. Molecules and chemical formulas are kind of an interesting thing. It turns out that in order to talk about molecules and chemical formulas, we kind of need to know what an element is. Okay, so I'm going to call up a periodic table, and on this periodic table, you can see that there are 118 elements. Okay, that is a finite number of elements. And yes, we make a new element once every year, every 2 years, but there's a limited number of elements. As a quick aside, Web Elements, to me, is one of the best online periodic tables. If you look up here, it's webelements.com. But the point is that all the elements have symbols, okay? And each symbol stands for an element. So there's 118 different symbols on the periodic table that all stand for different elements. Many of you know this already, like O stands for oxygen, B, boron, maybe not that one, but Al, aluminum, S, sulfur. Fe, that's kind of the niche one that everybody kind of likes, is because Fe stands for iron. Fe gets its symbol from the Latin ferium, and so ferium, F-E-R-I-U-M, so that's where iron is. But keep in mind, elements are made up of atoms, okay? Atoms are the smallest piece of matter, okay? They're the smallest unique piece of matter. So I'm gonna digress just for a minute. Okay, there was a guy back in about 500 BCE. His name was Democritus, and he had a student named Leucippus. And Democritus and Leucippus, they were really kind of interesting. Democritus and Leucippus were interesting folks because they sat around and they were philosophers, and they thought to themselves, what if we took a raindrop and we split that in half? And then we took another raindrop, and we took that half of a raindrop and split that in half. And then we have a half of a raindrop. So let me see if I can kind of symbolize. Here's a raindrop, then we cut it in half, then we cut it in half, then we cut it in half, cut it in half, cut it in half, cut it in half. And so what we're doing is we're continually cutting in half and half and half and half. They thought eventually that you're going to get to the smallest piece of a raindrop that couldn't be split anymore. And they called that atomos. Okay, that's the Greek word atomos, meaning smallest part. But the moral of the story is that there's a really small piece of matter called atoms that retain the properties of the larger element. For example, if you have one atom of iron, it's still magnetic, as opposed to a bajillion, manillion, quadrillion atoms of iron, that's magnetic. Once you start taking apart atoms and breaking them even further apart, which you can do, it loses the properties. So the atom is the smallest unique piece of matter. Okay? Now, forget about taking atoms apart. What we can do is we can take and put atoms together. Okay? That's where we can get compounds and molecules and things like that. Okay? To switch gears a little bit, so we have elements. Elements are found on the periodic table. Compounds are two or more elements smushed together. So you take two elements and you bind them together. Something stronger than just kind of putting them close to each other like a salad. You actually physically bind them together with, for lack of a better term, atomic glue, and that makes a compound. The smallest unique part of a compound is what we call a molecule. Okay? So, you have molecules and atoms. Okay? Molecules, of course, can be taken apart. For example, water, H2O, can be taken apart into oxygen atoms and hydrogen atoms. But in order for it to keep its properties of water, you have to have two hydrogen atoms and one oxygen atom together, glued together, so that they will then retain the properties of water. Okay, so let me see if I can summarize this. Okay, there are elements, periodic table. The smallest piece of an element is an atom. You can't go any smaller than an atom and have it still be an element. Then we transition to compounds, which are elements that are glued together. Those glued together compounds, the smallest part of those that you can have is something called a molecule. Okay, so a molecule, again, can be blown apart, but then it's not the compound again. Okay, so you have elements are made up of atoms, compounds are made up of molecules. Molecules are represented by chemical formulas, right? And so you guys probably know, and I just used one, okay, that you have H2O. This is a chemical formula. So this tells us what is in the molecule. H is a chemical symbol for hydrogen. You can look at a periodic table. Oxygen is O is the chemical symbol for oxygen. That's on the periodic table. And they're shoved together, and then we put a subscript here so that, let me see if I can write that neater so that it looks like it should, H2O. We put a subscript there. That subscript tells us how many hydrogens there are in a molecule of water. Okay? If there's no subscript, we assume it to be a 1. Okay? So something like NaCl, that's a molecule of sodium chloride. It's 1 sodium and 1 chlorine. Okay? Something like C6H12O6. There's a lot of atoms in there. There's a lot of elements in there, but that's 1 molecule of sugar. There's 6 carbons, 12 hydrogens, and 6 oxygens. Okay, so I'm going to talk about some weird exceptions, but they're not really weird exceptions, because if we know what a molecule is, then it makes sense. Okay, here we have Cl2. Cl2 we consider a molecule. Why is it a molecule? Because it's more than 1 atom shoved together. It's got a subscript there, so it's a molecule. But how many different things make it up? How many different things? It's only made up of chlorine. So it's an element. So it's an element because it's only one different, it's only one thing, but it's a molecule. So there's some subtleties about the definition. And then there's other things like sulfur. Sulfur in nature, if you've ever seen sulfur, it's a yellow powdery substance. Sulfur in nature is found as S8. And again, it's a molecule, but it's an element that's found as a molecule. Because elements are only one thing, one type of atom, and then molecules are many atoms shoved together. So, and then the last thing that the chapter talks about is, what if we have many of these molecules, or even elements? Okay, well, what we do is we can put a coefficient, a number out in front of the formula in order to symbolize how many of the molecules we're dealing with. So let me see if I can get rid of some of this writing. Okay, let's see. So we'll erase all this ink. Okay, so if we have, let's say, I don't know, something good, sodium chloride. Okay, but we're going to do something with 6 sodium chloride molecules. We're going to put a 6 out there. Okay, so that's how we symbolize having multiples of these. Let's say we're doing something with 12 water molecules. Okay, well, we put a 12 out in front of there. Okay, these numbers here, these coefficients and the subscripts, have to be whole numbers. That's the only kind of thing. You can't have H, you'll never see H2.3. Okay, oh, that doesn't ever exist. So all of these things are going to be whole numbers. Okay, so that goes over chapter 10 in the book and what we have in terms of making chemical formulas and molecules and atoms and elements, it can be a little confusing, so feel free to go back and rewatch, take notes, kind of understand what's going on, and have a great day.